All right, this is the last of our extra transformations practice examples. It's the third of 3 examples where horizontal and vertical stretches are included amongst our transformations. We've got some absolute value going on here. So when we go to write down the basic function, we know that it's going to be our friend, the absolute value function. And now let's list the transformations. I think it would be a great idea for you to pause the video here and list the transformations you think are here for comparison, whether you are kind of where you should be in terms of your understanding. Okay, so what do we have here? Well, we have this over 2. That's going to be something in the transformations, the stretches and compressions department. We have this x plus 1, so that's going to be a horizontal shift. And we have this minus 2, so that's going to be a vertical shift. So we have 3 transformations total, and one of them is stretch or compression. So we're going to start with that. Notice that we're dividing by 2 inside of the absolute value. So this is an x-coordinate transformation. And what you could do, if you find this helpful, is rather than writing it with a bar like that, x plus 1 over 2, you could write it as 1/2. Oops. Let me make it a little bit more clear. You could rewrite x plus 1 over 2 as 1/2 times x plus 1. That may be a little bit more familiar, it may feel a little bit more comfortable, but you can see here when you do that, or whether or not you do it really, that you've got stuff being multiplied by 1/2 inside of the operator. So this is a horizontal and it's a stretch, because 1/2 is less than 1. So it's a horizontal stretch by a factor of 2. So if we're starting our coordinate analysis and we're starting with some random point x, y on the graph of f, the horizontal stretch is going to land us at 2x, comma, y. Okay, so now let's think about that shift on the inside. Okay, so this plus 1, the x plus 1 over 2. Well, what you are seeing here is that because your 1/2 is on the outside, after you have stretched by a factor of 2, you're going to be shifting to the left by 1 unit. So this is another reason that you might consider rewriting your x plus 1 over 2 as 1/2 times x plus 1. For some of you, reframing it in that visual way is just going to be the help that you need to get it to look the right way for yourself to be able to recognize it. Continuing with our coordinate analysis, the shift left is not going to impact our y coordinate. It just stays the same. But it is going to decrease all of our x coordinates by 1. So we'll have 2x minus 1, comma, y. The last thing that we have left is dealing with this minus 2 on the outside. That's familiar. That's a shift down 2 units. So notice that any time that I talk about the transformation, I don't just talk about what kind of transformation it is. Is it a stretch? Is it a shift? Is it a reflection? I also have to specify exactly what's happening. So I have to say it's a shift left. I have to say it's a shift down, and how many units. I have to say that it's a stretch by a factor of 2. It's not enough to just say it's a horizontal stretch. You have to specify how much of a stretch. So really use this listing the transformation step to be really explicit about everything that's happening here. All right, so we were starting at 2x minus 1 comma y, and then we're shifting down. A shift down does not impact the x coordinate. It's just going to stay the same, but our y coordinate is going to be decreased by 2. So this is our final destination. If we start at the point xy and then we wind our way through the transformations, this is where we end up. So a point xy on the graph of f ends up at the point 2x minus 1, y minus 2 on the graph of g. Time to graph. As always, really nice axes. As close to vertical and horizontal as you can. Use a ruler if you are able. So here is my y-axis, here's my x-axis. Always label your axes. Starting with the graph of f. Again, use as many points as you need to. By now it should be a fairly familiar shape. This is a V shape. So it goes through the origin, the point 1, 1, the point negative 1, 1. Also 2, 2, and negative 2, 2. So whatever you need to see that shape, use that many points. Probably want to avoid using too many points just because then you have a lot of plugging in to do and you have a lot of plotting to do, but do allow yourself to use more points if you need more points. Okay, time for finding the transformed points. So we have negative 1, 1, 0, 0, and 1, 1 on the graph of f. And remember, these are our xy. And so let's figure out where these guys end up on the graph of g. So xy ends up at 2x minus 1, y minus 2. All right, so as always, we are plugging in these guys in for x and for y. That is the beauty of coordinate analysis. It takes those points on the original graph and it transforms them into their destinations on the transformed graph. So your graph is essentially reserved for your final draft. You don't have to do any kind of shifting and stretching or any of that on the graph itself. Okay, so where does negative 1, 1 end up? Well, if x is negative 1, 2x minus 1 is negative 3. And then if y is 1, y minus 2 is negative 1. 0, 0. So 0, 0. If x is 0, 2x minus 1 is negative 1. And if y is 0, y minus 2 is negative 2. If x is 1, then 2x minus 1 is negative 1. Oh, excuse me, 2x minus 1 is positive 1. And then if y is 1, then y minus 2 is negative 1. So let's see what we have here. Negative 3, negative 1. Negative 1, negative 2. And 1, negative 1. Alrighty. So you see, it's the same shape, but opened up. So the V is less pointed, but it's still a V shape that opens upward. It just does so more shallowly. So there is the graph of the absolute value of x plus 1 over 2 minus 2. That is the last of the extra transformations practice examples. I hope you've had a chance to both watch all 8 of these through, but also pause the video as you go to make sure that you are keeping up and that you are understanding and that you are doing it on your own as well. See you. Bye.